compared to the distance away. One can then make quantitative studies of the patterns from all the various slits here. You can make up slits of your own if you want to, but there's such a variety here, I think that ought to be instructive enough. That's all there is involved in this experiment, and it turns out to be extremely instructive in comparing what happens with the various slits. And for the 1, 2, and 3, and 4 slits, you can not only see the primary interference maxima, but you can see the weak secondary maxima in between the primary ones, and one should look out for those. That's all that one needs to do.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television. This is University of Colorado Television. Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment.
This experiment enables one to look at the interference and diffraction patterns produced by a great variety of slit spacings and separations. One uses as the source of the light for this a line filament, and just holds the plate up close to one's eye and looks at those. When in addition to this source has a second source, and one can use the filament, the central image of that second diffraction pattern, as a marker to mark off the position of the bands of the various diffraction patterns that one's interested in. Before starting the experiment, it's worth looking at the slit plate with the overhead projector that's in the laboratory, for example. Here's one, and although one won't be able to see in great detail what's going on, you can see a little bit of the various slits. There are a great many different kinds. There's a series of double slits here, and then with one single slit, and then a whole series of single slits of different width, and then a tapered single slit and a tapered double slit, and then slits of various multiplicities ranging from a single slit up to, I think, 40 or 80 slits in the width. In order to make quantitative measurements, one will have to know these slits widths and slit spacings, and that can be done by having a large magnification, even larger than here, and in the case of these wide multiple slits, counting the number of slits and then measuring the total width with the ruler and finding the scale factor by using measuring the millimeter scale on here. In the case of the narrower, simpler slits, one will simply measure the spacing directly off here and again compare with this. Having gotten the pattern of the slit and made the measurements, one can then start to look at the various patterns, and I guess to do that qualitatively first is best. One simply stands back and looks at the pattern here and picks out which one wants to look at and looks through here and can compare, for example, this whole range of single slits, looking at the pattern from each one and try and get some qualitative impression first. Then one can make quantitative measurements, and perhaps the best way to show that is to actually hold this up in front of a camera where the camera takes the place of the eye. But since the camera lens is larger than my eye, I'll have to block off all the pattern I want to look at with the screen. Otherwise, I would see more than one pattern. Now I can just see the one. If I stand back here and look, do you want to change the separation and turn on the light? If I look in here, and then we can see what's happening here in part of the television screen. Let's turn up the intensity, and I'll open up the f-stop lens of the lens, and I can see now the pattern from the upper and the lower filament, and I can see a diffraction maximum on each side. In fact, I can just barely see the other one. Now notice that if I move this around in a plane, nothing happens, simply because this is all a matter of angles and not of the position of this, and it doesn't matter what part of the lens I use. However, if I twist it like this, then I get a pattern in which any measurements would be false, and I want to be sure that the lines of the on the slit plate are parallel to the filament. Having done this, I can now start make measurements. Do you want to move that over a little bit and see what's happened here? Now you can, let's stop there and show what's happened. The central maxima are no longer together. The lower one is moved over a little bit. I'm going to use the central maximum as a marker, first for the blue, which is the inner edge of the first interference maximum. Let's move a little more. Keep going. Move more. Quite a lot more. Keep going. A little more. Keep going. Keep going. Right. A little more. Right about there, I'd say, was the blue. And now I can measure that distance over there. What is that? And now I can again measure the distance to the first red maximum. Let's go over. Keep going. I'll tell you when to stop. Keep going. Right there, the edge of the red maximum. How much further is that? So I can compare the wavelengths of blue and red, and actually, if I can measure the angles, I can find out what the actual wavelength is. I'll close down the stop here, and you can turn down the intensity. In order to do that, I will have to get two numbers. I'll have to get the distance from where my eye was and where the plate was to the lamp, so I'll just measure that off with a ruler or a tape. That'll give me one angle, and then I'll measure this distance, and that'll give me the long one is the radius, and this is the arc, and since it was far away, this is a fairly good measurement of the angle, and therefore I can find out what lambda is by knowing the slit widths and by knowing the angle at which the various maxima occurred. In addition to moving these back and forth, I can produce somewhat the same effect by standing back here and looking through here, and now I see, as I had before, that the central image along the first maxima. If I move over this, get closer, I can see the central image of the lower one coincident with the red of the second maxima of the upper one. Of course, I have to do the experiment in such a way that I fulfill the approximations. In other words, that I'm always far enough away so that I can consider the light essentially parallel, and also that when I measure the angle, the separation from the bulb is small.